Hello everyone and welcome to my channel Octopus Math by Sahiba. What does the prism tell you about the solid in the diagram? It tells us many things. You can say that the cross section is the right triangle ABC. You can say that the prism is uniformly divided into cross sections from A to E. You can call it, you can explain it any way you want. So I think talking about cross sections should be the ideal thing in this. Let's see what the marking scheme says. Constant cross sectional area. Yeah, that's what the prism is. Yeah. So we'll take that. Okay, show that AB is 3. So AB is 3 by Pythagoras theorem. AC squared is equal to AB squared plus BC squared. So AC is 5 squared, is AB is unknown, and BC is 4. So 25 minus 16 is 9 and X is 3. So we've shown it. Calculate the volume of the prism, give the units of your answer. Okay, so volume is base area into height, and base is this cross section, right? So the volume will be base area times height. Height is not the height of the triangle but height of the prism. So base area is the height of the triangle ABC. So area of the triangle will be half into base into height. So base is 4 and height we just calculated it to be 3. And the height of the prism is this 7. So 2, 3, 6 and 6 sevens are 42. And the centimeter square, it has centimeter cube, it has to be because it's volume, right? Let's check the answers. Square root of 9, 42 centimeter cubed, right? D on the 1 centimeter square grid, complete the net of the prism. Two faces have been drawn for you. So let's quickly check that this is 1, 2, 3, 4, 5, 6, 7. So this is 7 centimeter, and this is 3 centimeter, and this is 5 centimeter. So let's take a look at what shapes, what faces have been drawn. So one rectangle is 3 by 7 and the other rectangle is 5 by 7. The first rectangle was 3 by 7. So 3 by 7, AB was 3, right? And then this is 7. So DC is 7. So BF is also going to be 7. So when they're talking about 3 by 7, they're talking about the rectangle ABFE. And the other rectangle which was drawn was 5 by 7, and that is the rectangle A, uh, A, E, D, and C, right? This is the whole rectangle A, E, D, C. This is the whole rectangle that they are talking about, the second one, right? So now there are, if you notice this triangular prism, you have 5 faces. Front is a base. Front is the cross section, which is ABC. So I'm just going to quickly note down all the faces. Front is the triangle ABC. Back is the triangle EFD, right? And then we have AB, FE, the rectangle. And then we have AEDC. And then the last uh, the last face which is left is the bottom face, this BFDC, right? Okay, so what we need to take care of here is that the lines are to be aligned. Like for example, what I mean is that the length DC the length DC is attached from the base and this rectangle, right? I'm talking about DC. So if we uh, find anything, any line DC on the net, make sure we either connect it with the rectangle AEDC or the rectangle BFDC, right? All right. So when we talk about the net, there are two things that have been made already. One is this, right? And the other is the this face, right? So these two are connected. We understand that if this is 7, this also is 7, which means the common line between the two is this 7, which is AE. Now this basically tells us AE, right? So we have identified that this is A and this is E. And now from A to C, from A to B, it has to be 3. And from A to C, it has to be 5, right? So from if this is A, then from A to B, it had to be 3, right? And then from A to the like C, it had to be 5 because of what's been given, right? So we just have to label the numbers, I mean the dimensions, and then we are good to go. This is 4, this also is 4, this is 3. I'm just trying to label everything so it's easier for you to see, right? Okay, and then um we have I think E at the bottom. Yeah, so this is also 3 and then this is 5, so we need to see what's E is, right. So E and F are 3 units away and E and D are 5 units away. So E and F are 3 units away and E and D are 5 units away. Now let's see if BF is same as 7. So yeah, BF is 7 and also CD should be 7, right? So CD is also 7. So we have verified our net up to here. Now once we know that, once we have labeled the things that is already made here. So now let me change the color so it's easier for you to see other things. Now we need to draw all these shapes. All these other things. So ABFE is already made and AEDC is already made. Now let's talk about the triangle ABC, EFD, and the quadrilateral BFDC. Now we will see whichever is better for us to draw. So I was thinking if we would, because we know that AB and BC are perpendicular to each other, so we have to make sure that if we extended from B, because C is AB, if we are extending it, if you're making a triangle with AB as the baseline of the triangle, we need to make sure that C is right above B, and that too 4 units up, right? So 1, 2, 3, 4. This is going to be my point C. This is 4 centimeters, right? And this is going to be my, right? Okay, then moving on, this is also done. ABC is done. Okay, let's talk about EFD. So EFD is this triangle, the back one. We can extend it from, we can make it connecting FD or we can make it connecting EF. Let's see what we have. I think we have EF. So it should be the same way because it's all identical. So this D and this D should match because when you try to fold it back, this D and this ED and this ED have to be of same length, otherwise they wouldn't. You know, these letters are just for you to understand that if D would come back to the original position in 3 dimension, then it would move right above, right around D. E. So FD have to be 4 centimeters away and this will be 5, right? And then the last rectangle which is missing is BFDC. Now for BFDC, we can either connect it with FD or BF or DC or BC, right? So let's see what we can do. If I try to connect it with BF, is there a possibility? Yes. So BF is a line and it also has space. So let's do 7 by 4. So 7 is already here, and then this has to be 4. So 1, 2, 3, 4. And it will be C again because it has to meet with when you try to fold it, this line and this line will be like joined together. So if this is 4 units away from B, the C is, if the C is 4 units away from the C, then this C also has to be 4 centimeters away from B, otherwise it wouldn't, these two lines wouldn't meet, right? So this point again, it has to be the same as this point D, right? Otherwise this DF here and this DF would not coincide, right? So I think we are done with the net. Part E, calculate the surface area for the prism. So let's check it from the net only. Now there is these 1, 2, 3, 4, 5. So for any surface area problem, what I tell my students is to not memorize the formula for the whole shape. You just calculate the surface area for the each individual shape that is involved in the 3D shape, and then you can quickly, and then you can find out the areas for each individual shape, and then you add them up. So you get the total surface area of this prism. So for shape number 1, it's 4 by 7, so it's 28. For shape number 2, it's a triangle ABC, so 1 times 2, and because these are two triangles, 1/2 of 4 times 3, right? So it's the same thing. And then we have rectangle 3, which is 21. And then we have rectangle 4, which is 35. 5 times 7 is 35, right? 96 centimeters square is the answer. Let's check it from the marking scheme. Um, Correct net drawn. Okay, 96, yeah. Okay, so 96, right. Thank you for watching. Share my videos with your friends and family to spread the knowledge. Also, keep watching for more videos.